Hello everyone. What I'd like to do today is go over the homework questions that were assigned in the last lesson. Those homework questions all had to do with horizontal translations. So if you remember what the formula looks like for a quadratic that we're dealing with transformations in, that's the general form. But we're only going to be looking at the x minus h part, and the a part might come into play as well. So the k value is going to be 0, which means the parabola won't have moved up or down, but this means move left or right. Just a quick reminder, if the sign inside the bracket is a negative, that means the parabola is moving right. If the sign inside of the bracket is positive, that means the parabola is moving left. So question number 1, they show you pictures of transformations of parabolas, and they ask you for each solid parabola, identify the value of h and the coordinates of the vertex. So the dotted line parabola here is the original parabola, and the solid line one is the one that's moved. Okay, so we need to find the value of h and the coordinates of the vertex. So you have to be able to count. Now it's a little bit hard to see, but you have to count the little tick marks showing how far the parabola has moved. So if we look at this one, it's 1, 2, 3, 4, 5. So for a, our h value is going to be 5. But that means inside the bracket, it would be x minus 5. Okay, so that's how that works. When you sub in the h into the bracket here, the minus sign is going to change its sign over. Okay, now what are the coordinates of the vertex then? The coordinates of the vertex would be 5, 0, because the h value is 5, the k value is 0. For b, our parabola moved left by, it looks like 1, 2, 3. It's a little hard to see there. So that means our h value is going to be negative 3, but when we put it in the bracket, it's going to be x minus negative 3, which gives x plus 3. So there's the switch over of signs once you put it into the bracket. Our coordinate of our vertex, would be negative 3 and 0. For c, again, this parabola moved to the left. It looks like 1, 2, 3, 4, 5, 6, 7 to the left. So that means h would be negative 7, which would mean in our bracket we'd have x minus negative 7, which would be x plus 7. Coordinates of our vertex would be negative 7, 0. Now in this one, I know it doesn't ask for what the a value is, but I do want you to notice that the parabola is upside down, and that means that the a value would be negative. We don't know what the number is. We'd have to do some calculations for that, which we can't because this is not an accurate enough representation, but we do know that the a value is going to be negative. Same thing for d. We know the a value is going to be negative. But it's moved to the it looks like it's moved to the right by 2 for d. So that means h is equal to 2. But in the bracket, that would be x it would be x minus 2, sorry. And then our vertex would be 2, 0. And our a value would be negative. So those are the answers to question 1. In question 2, I only asked you to do A, B, C, and D. And And it says, describe the graph of each parabola relative to the graph of y equals x squared in terms of a and h. Sketch each graph. And I had suggested that you don't need to sketch them. So when I ask you a question like describe the graph, what I'd really like you to tell me, on top of saying what a and h is which way did it move? Was it stretched? Was it compressed? Is it reflected upside down? Okay. So if we look at letter A is y is equal to x minus 7 squared. So what is our a value? Well, there's no a value there, but it's a number that's multiplying the bracket. So we know that that number is going to be a 1. So a is equal to 1. Now what is h equal to? H is equal to positive 7. Because it's a negative 7 in the bracket, h is actually the positive value of that. Okay? So what does that a equals 1 mean? That a equals 1 means that the parabola didn't get stretched, didn't get compressed, and isn't upside down. So it's a normal parabola. What does the h equals 7 mean? It means moved right by 7. Remember, if it's a negative in the bracket, it means it's moving right. Okay? For b, we have y is equal to negative x plus 3 squared. This time our a value is negative 1, which means upside down. But because it's a 1, it means there's no stretch or compress. So it's still the normal shape, but it's just upside down. Our h value is equal to negative 3. Remember, it's always the opposite of what the sign is inside the bracket. And that means that it's moving to the right. Sorry, it's moving to the left by 3. See, I almost made the mistake there. It's a little confusing when you take the h value out and see the negative sign here. It's the sign inside the bracket that is opposite the direction. The h sign is actually in the same direction as which way it's moving. But that's very confusing. So normally I don't even tell my students to take the h value out. I just say take the value inside the bracket and go the opposite direction. Okay? So plus 3 means left by 3. And I mean, if I wanted to sketch these parabolas, it would be pretty easy. I mean, if I'm not asking for a really accurate sketch, so that would be the sketch for A, and the sketch for B would look like that. Okay? So for C, we have y is equal to 1.5 x plus 8 squared. And our a value is 1.5. Our h value is negative 8. That means that the parabola for the a value got stretched. This is a number greater than 1. It's a decimal greater than 1. So any number greater than 1 is going to stretch the parabola. So it's going to be narrower. And then h equals negative 8, or x plus 8 means that it's moving left by 8. So if I sketch that parabola, it would be a narrower parabola at x equals negative 8. For D, what do we got? Y is equal to negative 0.8 times x minus 2 squared. So our a value is negative 0.8. Our h value is 2. So what does negative 0.8 means? It means, so first of all, it's upside down. And then if we look at just the number part of 8, the number part of A, which is 0.8, that means that it's compressed. For our H value, which is coming from our bracket, x minus 2 means right by 2. So if we then graph this parabola, I'm going to need more room down below here. Right by 2, so our vertex is about here. It's upside down and compressed, which means it's wider, which I probably should write here. Okay, so I'm exaggerating it a little bit just so you can see that it's wider than it was before. And that's all of question 2. The next question is question 5. I had asked you to do A, B, and D. So for this question, suppose each pair of relations were graphed on one set of axes, which parabola would have its vertex farther from the y-axis? Justify your answer. So we had done a question similar to this a little while ago, where it said how far away would it be from the x-axis if the parabola moved up or down. Now we're talking about the y-axis. So which one is further away from the y-axis, moving left or right? So these are pretty easy. All we have to do is look at the h values in both, and whichever one has the bigger h value is going to be the one that's moving. And that's the h value without the sign, because whether it moves left or right, it's still going to be further away from the other one if it's got a bigger, like, numerical value. So we've got a +3 and a +1. So the first one is further from the y-axis, okay? Because moving 3 to the left is bigger than moving 1 to the left. Okay? For B, we've got -3 and -8, which means both are moving to the right. So the 8 is bigger. Moving to the right by 8 is bigger than moving to the right by 3. Okay? And in D is a situation where we have two different signs, but still the number itself is what we're interested in here. Moving to the left by 9, so the second one is the one that's further away. So left by 9 is bigger. Maybe I should have used the word further, whatever. Than right by 2. And that's it for question number 5. Which brings us to the last question, number 7. The side view of a car headlight shows that the back part of the headlight is parabolic. For the headlight shown, the shape of the parabolic part can be modeled by the relation d is equal to 0.08 times w minus 7 squared, where d is the depth, so this length here is the depth, and w is the width of the headlight from edge to edge. Draw a graph to represent the shape of the back part of the headlight. So they wanted us to draw this graph, okay? That means that we have to use our transformations table of values to be able to do it, all right? So I'm going to set that up down here. Now if you remember, now as a bit of an, I think this is an introduction idea to the next lesson, but we've always been doing -2, -1, 0, 1, 2 up to this point. We're just going to do 0, 1, 2 now, okay? Because I know that the parabola is symmetrical, so if I can tell what the points are on the right-hand side of the vertex, I just have to mirror them on the left-hand side. So this really reduces the amount of work that we have to do, okay? We also have x transformations, so I left some room here. I'm going to put in my normal y values, which are 0, 1, and 4, and now let's transform those y values. So we're moving to the right by 7. Just to be clear, why are we moving to the right by 7? Because if you look at the h transformation, which is inside the bracket, it's a -7, which is actually the opposite direction, which is +7. Okay? Our y values are all going to be multiplied by 0.08. Now, what does that do to a parabola? What happens when our a value is a number between 0 and 1? That means it's going to be compressed. Okay? You can kind of tell by the shape of this parabola here that it's going to be wider than the normal parabola. So what are our new x and y coordinates? Our x coordinate is 7, 8, and 9. Now for our y coordinates, I'm probably going to have to use a calculator for some of those, so I'm going to get it ready right now. So the first one's easy. 0 times 0.08 is 0. Second one is easy. 1 times 0.08 is just 0.08. And the last one is 4 times 0.08. So I'm just going to calculate that. 4 times 0.08 is equal to 0.32. And now I'm ready to sketch the parabola, which I'm going to do up here. Okay. Now I want you to notice, using this new method, that this point was our vertex, which is now that point. So if you think about where our vertex is, 7 on the x-axis and 0 on the y-axis, that means for my graph, I'm going to need more room on the right of the graph than on the left of the graph, because the whole parabola is moved over to 7. So I'm going to put the 7 right here. Actually, I want to use a different color for that. So that's where my 7 is. Okay. So the first dot of my parabola is at 7, 0, which means it's right here. So normally the vertex is at 0, 0. It's moved to the right by 7. Now when I go to 8, and here's where we can play around with the scaling a little bit. Let's put our one height right here. But 0.08 is like really small. So it's right near the x-axis. I mean, I can't even almost draw it because it's too close to the dash for 8. And then at 9, it's at 0.32, which is still not even halfway up. Okay, so that's just a little bit higher. And what I'm going to do the left-hand side, so remember, these are the 3 points on the right-hand side of the parabola, right? 7, 8, and 9 means we're going to the right-hand side. We have to draw the left-hand side. So it's sometimes a good idea to draw the axis of symmetry of the parabola. And I did not get it in the right spot. Let me move it here. So that's the axis of symmetry, which is the line that goes through the vertex always. And now I can just mirror those points on the other side. So there'd be one about here, and there'd be one about here. Now drawing the parabola is very difficult to do on this tablet, so I'll give it a shot. I'm going to do it in purple. And that's the best I can do. Okay. Now before I continue to question B, this is all question A. Why is a headlight parabolic? In science, there's a section of the science course that's called optics. Now I don't know if you should have done a little bit of optics at this point. But with parabolic mirrors, interesting things happen. I'm just going to explain it quickly. If you put a light source at what we call the focus or focal point of a parabolic mirror, every light beam coming off of that light source is going to leave parallel to each other. Okay, so every light source that comes off is going to leave parallel to each other. It's really hard to draw everything parallel. So that's going to make your headlight a lot brighter and going basically straight out in front of the car to be able to illuminate the road out in front of you. So that's why you have a parabolic shape to your mirror, is so that when you put a light source, and by the way, this is how flashlights work too. Now, you know, I don't know about the light on your phone, if it actually has a parabolic mirror behind it or not. Because it's an LED, it's pretty bright. It might actually have a lens in front of it instead. But for flashlights, they usually have a mirror in the back if you look at a flashlight. Don't look at it with the light turned on. But that is to focus that beam, to make it go all out. Sorry, focusing is the wrong word there. It's to make all the light sources parallel as they come off the mirror, so that it extends the distance in front of the light. Okay, so that's why we have parabolic mirrors for cars. And I mean, somebody had to calculate that to make those mirrors accurate. Somebody needs to know the formula for that. Okay, so the next question says, how wide is the headlight when the parabola is 4 centimeters deep? Now, when you see a question like that, if I'm giving you a number, usually I'm asking you to substitute that number into the equation. Well, where should the 4 go? Should the 4 go where the D is, or should the 4 go where the W is? Well, I'm asking you to calculate a width, right? So that means it's not going to be the W, because if I just put it where the W is, I'd know the answer already. But it also says 4 centimeters deep. That's a depth. So we have to put the 4 where the D is, 0.08, and then the W minus 7 stays the same. I'm just going to make sure I've got that right. Yep. Okay. So now we've got to isolate W. Now, we haven't isolated W before. So this is going to be the first time you see this, and it was a little bit of a challenge question. But we have isolated A. Okay. So we have done some isolating. We just haven't isolated W before. So let's talk how we get W by itself. Now, with algebra, the way it works is you're usually working your way outside into the variable, okay? The minus 7 is right next to the W. That's like too close. The 0.08 is actually what we have to get rid of first here. So the 0.08 is multiplying. That means it's going to come over here and divide. Now, something's going to happen here that some students get confused with, and I think we've already talked about it at least once in class. What happens when you divide a big number like 4 by a very, very small number like 0.08? Should your overall answer be small, or should your overall answer be big? And a lot of students somehow think that it's supposed to be a small number there. But think about it. How many times does 0.08 fit into 4, which is what a division means, right? Like if you divide 4 by 2, it means how many times does 2 go into 4? Well, if you divide 4 by 0.08, how many times does 0.08 go into 4? And it goes in quite a lot. So I'm just going to do that division off to the side, make sure I don't make a mistake here. So 4 divided by 0.08 is actually 50. Okay, so the answer got bigger, and it was supposed to. Now, we have to get W by itself. Unfortunately, W is trapped inside of this square. Well, what kills a square? The symbol that kills a square is a square root. So that's what we're going to do. We're going to square root both sides. And what that does on this side is it just leaves us with W minus 7, because square rooting a square just gives you the bracket itself. On this side, I'll square root 50 on my calculator. That gives 7.07 approximately. Okay. And now we've got to get W all by itself by moving the 7 over to the other side. Well, 7 is subtracting So what is it going to do on the other side? It's going to add. So we get, 7.07 plus 7 is equal to W, and that means that W is equal to 14.07. So for our depth to be 4 centimeters, our width of our parabola has to be 14. Okay? So that's it for the homework correction. So hopefully that helped you if you had any trouble with the homework, and we'll talk to you tomorrow.